Yeah, good morning, my dear students. So, in the previous class, we have seen important and easy topics which are used in our subject. Till here, we completed coefficient of concurrent deviation. And these are the merits of concurrent deviation. Right. So, the merits of concurrent deviation here, it is easy to calculate. Number one, it is simple to understand. This method can be fruitfully used when only type of correlation is to be computed. Demerits of concurrent deviation. It is only a rough measure of correlation. Calculate the presence of absence or correlation. This method cannot be this method cannot be used for further statistical analysis. Okay, so this method right. Okay, so this method combine R or cannot be calculated as different series. Okay, so till here we completed and it is very easy. Oh, now we will see the another new topic, scatter diagram method. This the simplest device for ascertaining whether two variables are related is to prepare a dot chart called scatter diagram. The simplest device for ascertaining whether two variables are related is to prepare a dot chart called scatter diagram. When this method is used, the given data are plotted on a graph paper in a form of dots. That is, for each pair of x and y values, we put a dot and thus obtain as many points as the number of observations. By looking to the scatter of the various points can form an idea as to whether the variables are related or not. Okay, the greater the scatter of the plotted points on the chart, the lesser is the relationship between the variables. So the more closely the point come to a straight line falling from the lower left hand corner to the upper right hand corner, correlation is said to be perfectly positive. That is R is equal to +1. Observe the below diagram. So this is a perfect positive correlation. Okay. See, perfect positive correlation. It begins from the left side and moves towards the right direction. Lower left hand corner to the upper right hand corner. So you have to write here in this way and keep the dots. On the other hand, if all the points are lying on a straight line, rising from the upper left corner to the lower right hand corner of the diagram, correlation is said to be perfect and negative. That is R is equals to -1. So you observe this diagram. This is completely opposite direction. If the plotted points fall in a narrow band, there would be a high degree of correlation between the variables. Correlation shall be positive. If the points show a rising tendency from the lower left hand corner to the upper right hand corner, okay, then this is the low degree of positive correlation. Okay, the next one, negative. Negative if the points shows a declining tendency from the upper left hand corner to the lower right hand corner, lower degree of negative correlation. On the other hand, if the points are widely scattered over the diagram, it indicates a very little relationship between the variables. Correlation shall be positive if the points are rising from the lower left hand corner to the upper right hand corner. If the plotted points lie on a straight line parallel to the x-axis, it shows absence of any relationship between the variables. That is, r is equals to 0. We can say that no correlation. No correlation. Okay. No correlation, we can say. Okay. Then we'll see a small problem. You observe the problem carefully. Given the following pairs of values of the variables x and y. So you see the problem carefully. Please go through the problem. Yeah. Make a scatter diagram. Right, number one. Is there any correlation between the variables x and y? By graphic inspection, draw an estimating line. Okay. So here x, y, 2, 3, 5, 6, 8, 9, 5, 6, 7, 8, 12, 11. Okay, according to that. So in this way, it begins from the lower left corner and moves towards the right corner. Okay, right. The next over here. By looking at the scatter diagram, we can say that the variables x and y are correlated. Further, correlation is positive because the trend of points is upward rising from the lower left hand corner to the upper right hand corner of the diagram. The diagram also indicates that the degree of relationship is higher because the plotted points are near to the line which shows perfect perfect relationship between the variables. Okay, so this is the scatter diagram method. Okay, x values, y values. So see here we have written the y values and x values. Then we got the straight line. So by looking at this scatter, we can say that the variables x and y are correlated. Further, correlation is positive because the trend of points is upward rising from the lower left hand corner to the upper right hand corner of the diagram. The diagram also indicates that the degree of relationship is higher because the plotted points are near to the line which shows which shows perfect relationship between the variables. In this we have to write. Then next over here, the next method is graphic method. Okay, graphic method. Graphic method. When this method is used, the individual values of two variables are plotted on the graph paper. We thus obtain two curves, one for x variables and another for y variable. By examining the direction and closeness of the two curves, so drawn, we can infer whether or not the variables are related. If both the curves drawn on the graph are moving in the same direction, either upward or downward, correlation is said to be positive. On the other hand, if the curves are moving in the opposite directions, correlation is said to be negative. Okay. From the following data, ascertain whether the income and expenditure of 100 workers of a factory are correlated. So in this, the question will be there. So from the year 1989 to 1990, 1991, 1992, 1993, 1994, 1995, 1996, 1995, 1998. Average income, average expenditure. Okay. So according to this, see the baseline is the here years and the left side income and expenditure. See, in this way, the income and expenditure will begins. So we got on the dotted lines and the straight line we drawn. So this method is normally used when where we given data over a period of time. That is in case of time series. However, with the scatter diagram method, in this method also we cannot get a numerical value describing the extent to which the variants are related. Okay. Mm. Right. I think you understood, my dear students. So anybody have any doubt, please ask the doubt. Right. The next one is regression analysis. Regression analysis is a statistical device with the help of which we are in a position to estimate the unknown values of one variable for the known values of another variable. The estimation of future production, the estimation of future production, consumption, prices, investments, sales, profits, incomes, etc. are of great importance to a businessman. Okay, so in regression analysis, this is also one of the important statistical device with the help of which we are in a position to estimate the unknown values with the known values of another value, known values of the another variable. So this is the variable or value you can take. The estimation of future production, consumption, prices, investments, sales, profits, incomes, etc. are of great importance to a businessman. With the help of regression analysis, we can estimate the effect of one variable on the other variable. So regression analysis attempted to analyze the nature of relationship between variables. That is to study the functional relationship between the variables and thereby provide a mechanism for estimation or for forecasting. The regression analysis, which studies more than two variables at a time, is called multiple regression, whereas which confines itself to a study of only two variables is called as simple correlation. In simple correlation, only there are two variables. Okay, so that is independent variable regressor. This is called predictor. The dependent variable regressed variables. Then two variables are x and y, and their regression equations are So regression equation of x and y, regression equation of y and y on x. So x on y and y on x, we are going to do the following formulas are applied for both the regression equations. They are as follows. So regression equation of x on y. So again, this regression equation x on y and y on x, actual mean as well as assumed mean. What we done the problems in correlation analysis, the same situation. So this is the actual mean formula. By heading formula is very much important here. So actual mean x minus x bar is equals to r into standard deviation x by standard deviation y into y minus y bar. Then r into standard deviation x by standard deviation y is equals to bxy is equals to sigma xy divided by sigma y square. Where x is equals to x minus x bar, y is equal to y minus y bar. So x bar is equals to sigma x by n, y bar is equal to sigma y by n. Then assumed mean. Okay. So you, my dear students, you observe the formulas only. So while we are doing the problem, you are going to get the clarity that difference between actual mean and assumed mean. You will see the difference. Right. So you observe carefully. See, r into dx divided by dy is equal to sigma dx into dy minus sigma dx dy minus sigma dx into dy divided by n. Again, it is divided by sigma dy square minus dy whole square by n. Okay, that is x on y. Then y on x here. Y minus y. It is complete reverse. Y minus y bar is equals to r into standard deviation y by standard deviation x into x minus x bar. Okay. Then r is equals to r into standard deviation y by standard deviation x is equals to byx is equals to sigma yx divided by sigma x square. Okay. So that does it with r into standard say dy divided by dx is equals to sigma dx into dy divided minus sigma dx into dy by n divided by dx square minus sigma dx whole square by n. Okay, this is assumed mean. So to find the correlation coefficient of correlation r is equals to under root bxy into byx. Okay, so we see the problem. Problems of regression equations. From the data given below, find the two regression equations. First question is the two regression equations. The second one is the coefficient of correlation between the marks in economics and statistics. The most likely marks in statistics when marks in economics are 30. See, known information is given. So we are going to find with the help of this known information the unknown values. Okay. So marks in economics 25, 28, 35, 32, 31, 36, 29, 38, 34, 32. Marks in statistics 43, 46, 49, 41, 36, 32, 31, 30, 33, then 39. So as usual, same. See, two regression equations. First question, coefficient of correlation between the marks in economics and statistics. Second question. The next known values are will again. So we are going to find out the unknown information. Okay, right. So solution x, y. So x, y we copied from the question paper only. The next immediately x minus x bar is equal to how much? y y minus y bar is equals to how much? Okay. Okay. So you observe it carefully. So here x bar we have to find out and y bar. X bar sigma x by n is the formula. So 320 divided by 10 is equals to 32. Y bar is equals to sigma y by n is equals to 380 by 10, that is 38. So we didn't got the decibel values. So what we done in correlation analysis, the same situation is there. So you need to take that values only 32 and 38, x minus x bar. So here x is 25, x bar is 32, minus 4, 7 minus 4, remaining likewise. Yeah. So these 32, 38. Okay. Okay. So here with the 32, 25 minus 32 minus 7, 28 minus 32 minus 4, 35 minus 32, that is 3. So in this way we have to identify the values. And y is equals to y minus y bar. So that is 38. 43 minus 38, 46 minus 38, 49 minus 38, 41 minus 38, 46, 36 minus 38. Okay. So getting these values simply x square y square, 7 square 49, 4 square 16, 3 square 9, 0 square 0, 1 square 1, 4 square 16, 3 square 9, 6 square 36, 2 square 4, then 0 square 0. Okay. The remaining y square also. Same procedure. In procedure there is no change. Same procedure. See, this method is very much interesting subject here. Y square. Next one is minus 35. Sorry, 25, 64, 121, 9, 4, 36, 49, 64, 25, 1. Sigma y square is equal to 398. So we got x square and we got y square. Then xy. Okay, x 7 5 is 35. 4 8 is 32. So in this way, we are going to get these values. Okay, x into y. So sigma xy values minus 93. Please go through. I will. Okay. So after getting all these values, simply see here we got decimals. Hmm? So what we have to do? We go for actual mean method. Formula. This is the formula in both cases. Then next over here, x is equal to 32 is equal to 0.23 into y minus 38. So finally, this is the x on y. Then calculation of y on x. Y minus y bar is equals to r into standard deviation y divided by standard deviation x into x minus x bar. Okay, so this is the formula. So you observe carefully, my dear students. This case, r into standard deviation y divided by standard deviation x. So see, this is written as byx. Again, byx also written as sigma xy divided by sigma x square is equal to, okay, minus 93 divided by 140. That is 0 minus 0.66. Okay, so after getting all the values, y is equals to minus 0.66 x plus 59.12. Then coefficient of correlation r is equals to under root b x y into byx. Okay, so here bxy, how much we got? Minus 0.23 into minus 0.66. So that is the final answer is 0.38. So for ascertaining the most likely marks in statistics, when in economics are 30, we have to use the regression equation of y on x. Okay, so in this way we are going to get the remaining value, the next value. Okay, this is about the actual mean method problems. So these are the practice problems. So please, my dear students. So this is a practice problem. You observe carefully. From the following data, obtain the two regression equation and coefficient of correlation. Sales, purchases 91, 97, 108, 121, 67, 124, 51, 73, 111, 57. Then purchases 71, 75, 69, 97, 70, 91, 39, 61, 80, 47. So you did this problem, same this method only. Okay. The next regression equation, x on y and y on x, deviations taken from assumed mean method. When actual mean of x and y variables are in fractions, that is in decimals, the calculations can be simplified by taking the deviations from the assumed means. When deviations are taken from assumed mean, the entire procedure of finding regression equations remains the same. The only difference is that instead of taking deviations from actual means, we take the deviation from assumed mean. The two regression equations are here. Okay, x minus x bar is equals to r into standard deviation x by standard deviation y into y minus y bar. The value of x minus x bar is equal to r into standard deviation x by standard deviation y into y minus y bar will now be obtained as follows. Okay, so this you observe carefully. So this place r into standard deviation x by standard deviation y will be written as r into dx by dy is equals to standard sigma dx into dy, sigma ds dy minus sigma dx into dy divided by n divided by sigma dy square minus dy whole square by n. Okay. So you see the problem. From the following data obtain two regression lines. Okay, same question. It looks very same. The thing is here, see, we got these values. But here, x bar value you need to find identify. So x bar value is different. So we got these values. So dx, x minus a is equals to 2. We can take any number. What we done in correlation, the same procedure. You can take 2, 6, 8, 11, 13, okay, 13, 13, then 14, okay, 8, 6, 10, 12, 12, 14, 14, 20. So x, y. Then dx x minus a, that is a is equals to 2. And here a is equals to 8. So 2 minus 2, that is 0, 8 minus 8, that is 0. So dx square, these are the values, dy square, this is value, dx and dy, we got the values. So after getting all these values, we go for regression equation x on y. That is x minus x bar is equals to r into standard deviation x by standard deviation y into y minus y bar. The value of x minus x bar is equals to r into standard deviation x by standard deviation y into y minus y bar will now be obtained as follows. Okay, in this way we are going to get the values. So the assumed mean values are dx square is equals to 640, dy square is equals to 256, dx dy is equals to 360, dx is equals to 64, dy is equals to 32. So finally we are going to get the 0.812, that is the value, and here y on x here. It is quite it is completely, it is opposite direction. Then coefficient of correlation is equals to under root bxy into byx, 0.812 into 0.812. So you will got the value 0.812 only. Okay. So this is a practice problem. If you practice this problem, you are going to solve any type of problem regarding correlation topic. Okay. So at this, we are going to conclude the regression analysis also. So this is a practice problem. The following table shows the ages X and blood pressure of 8 persons. X, Y, 52, 63, 45, 36, 72, 65, 47, 25. In Y, okay, 62, 53, 51, 25, 79, 43, 60, 33. Obtain the regression equation of X on Y, Y and Y on X. So X on Y and Y on X. Okay, this way the examiner will ask the question. But the thing is here, sometimes what happens, he will not ask. Okay, he will ask in this way: obtain X on Y and Y on X, or simply he will ask obtain two regression lines. Okay, so we need to identify. Okay, at this we completed the regression analysis. Regression analysis we completed. Then we go for the statistical estimation and hypothesis testing. So this is also a big chapter. That is unit number 13 and 14, 15, 16, 17, 18. Okay. So wait a minute, I will share the screen. Does my dear students stay in the class? and testing of hypothesis. Oh, so statistical estimation and hypothesis testing. Introduction to testing of hypothesis, test of significance of attributes, hmm, uh, attributes, test of significance large sample, test of significance small sample. Okay, right. So here the statistical inferences is that branch of statistics which is concerned with using probability concept to has the with uncertainty is decision making. The field of statistical inference has had a fruitful development since the latter half of the 19th century. So here it refers to the process of selecting and using a sample statistic to draw inference about a population parameter based on subset of it, the sample drawn from the population. Statistical inference treats the two different classes of problem. That is number one, hypothesis testing. To test some hypothesis about parent population from which the sample is drawn. Then estimation. To use the statistics obtained from the sample as estimate of the unknown parameter of the population from which the sample is drawn. Okay. Then here hypothesis testing here. So hypothesis testing begins with an assumption called a hypothesis that we make about a population parameter. A hypothesis is a supposition made as a basis for reasoning. Okay, so this is assumption and supposition. We sometimes you can say or example also. So according to Professor Maurice Hamburg, a hypothesis in statistics is simply a quantitative statement about a population. Quantitative, not qualitative. Quantitative statement about the population. Okay. Then next over here, Palmer O. Johnson has beautifully described hypothesis as islands in the uncharted seas of thought to be used as basis for consolidation and recuperation as we advance into unknown. Okay. Then next year, there are several types of hypotheses. For example, a coin may be tossed 200 times and we may get heads. So there are several types of hypotheses. For example, a coin may be tossed 200 times as we may get heads 200 times and tails 120 or may now be interested in testing. Okay, the hypothesis is that the coin is unbiased. Okay, so parameter a limit defining the scope of an activity. The recuperation is recovering from illness or regain. So here procedure of testing hypothesis. So this procedure you have to follow, my dear students. The following procedure of testing hypothesis is briefly described below. Setting up a hypothesis, null hypothesis H naught, mu is equals to H naught. It is very important. It is very useful tool in testing the significance of difference. Hence the word null, which means invalid, void, or amounting to nothing, and that the difference found is accidental and really important assigned out by the fluctuation of sampling. Then alternate hypothesis. H here, mu is not equal to H naught. However, for statistical convenience, it will make a difference as to which hypothesis is called null hypothesis and which is called the alternative, in setting suitable significance level. Having set up a hypothesis is the next step is to test the validity of H naught against that of HA as a certain level of significance. The confidence with which an experiment rejects or accepts a null hypothesis depends upon the significance level. The significance level is customarily expressed as a percentage such as 5% and 1%. Okay, 5% and 1%. Here, a level of significance 5% is the probability of rejecting the null hypothesis if it is true. So 5% significance level, that is 95% confidence level. 1.96 is the table value or critical value, you can say. So 1% significance level, 99% confidence level, that is 2.58 is the critical value. Setting a test criteria. So in this test, so these are the steps, and this is doing calculation, making decisions. Okay, making a decision means right after solving the problem, we need to write a decision. That is very much important. An estimation. See, when data are collected by sampling from a population, the most important objective of statistical analysis, draw inferences, are generalization about the population from the information carried in the sample. Statistical estimation is concerned with the methods by which population characteristics are estimated from sample information. It may be pointed out that the true value of parameter is an unknown constant that can be correctly ascertained only by an exhaustive detailed study of the population statistical estimation procedure. Provide with the mean of obtaining estimation of population with a desired degree of precision. The following two types of estimate are possible. That is point estimate, interval estimate. The point estimation is a single number which is used an estimate of unknown population parameter. The interval estimate. An interval estimation of population parameter is statement of two values between which it is estimated that the parameter lives. An interval estimates would always be satisfied and specified by two values such as lower value and the higher value. This is called as interval estimate. Okay, so in more technical terms, interval estimation refers to the estimation of parameter by a random interval is called the confidence interval. Okay, so now we are slowly entering into the problematic part here. So the properties of a good estimator. The following are the properties of a good estimator. That is unbiasedness, consistency, efficiency, sufficiency. Unbiasedness. Unbiased means should not argue or we can say in Telugu నిష్పక్షపాతం లేకుండా. For example, for unbiasedness, see, I want to share one small a good example, that is coin. A coin is a unbiased coin. See why? Because see, coin we invented. So for example, there is a match between India and Pakistan that is on Friday. Okay, it is a sentiment for the Pakistan people that if you play the game with India on Friday, that you are going to win the match. Okay, but the thing is here, so unbiasedness. So in unbiased here, a coin is an unbiased coin. So coin will not act as a partiality among any team. Okay, it will come head or tail. Any result it will come. Then consistency. A constant So consistency. The data should be consistent and efficiency. So efficiency means here with little efforts, we need to do more with little efforts. We should go more result. Sufficiency. Sufficiency means according to our requirement, we should develop sufficient situation or sufficient problem or sufficient information we need to gather. So now we are slowly entering into problematic what that is types of testing significance. The following are the various situations or types of different test of significance. Number one, test of significance for attributes. Then number two, test of significance for variables, large samples. Then number three, test of significance for variables, small samples. Attributes, large samples, small samples. Okay. So test of significance for attributes, that is the various tests and significance for attributes are discussed under the following heads. That is test for number of success, test for proportion of success, test for difference between proportions. So test for number of success. The sampling distribution of number of success follows a binomial probability distributions. Hence, it is a standard error given by the following formula. So this is the formula. So see, if we do problem, then you are going to clarify the doubt. So the problems are there here. Coin was tossed 400 times and head turned up 216 times. Test the hypothesis that coin is unbiased. So that is solution here. So setting hypothesis, null hypothesis H naught, mu is equal to H naught, coin is unbiased. Alternative hypothesis HA, mu is not equal to HA, rejected. Okay, setting suitable significance level. So in the given question, 5% is given means we go for the 5%, this one. If 1% is given means we go for the 1%. Okay, so here these values are held as critical values. So after calculated value, we are going to find, suppose we got a calculated value. So based on that calculated value, we are going to compare with these critical values, that 1.96 and 2.58. Okay, so here you observe carefully. In the given question, 1% is not given, 5% is also not given. So we have to assume that 5% only, we have to assume, and we have to take 5% only. At 5% significance level, 95% confidence level is 1.96. At 1% significance level, that is 99%, confidence level is 2.58. Okay. So then the third step is the test criterion. In test criterion, see, based on the problem, according to the problem, this problem belongs to which method, which formula we need to uh, apply. You have to decide at this stage only. That is the standard error of number of success is equals to under root NPQ. N is equal to size of samples, P is equal to probability of success, Q is equal to 1 minus P, that is probability of failure. The standard error is equals to difference divided by standard error number of success. Okay. Then doing calculation. When kind is unbiased, see, the kind is unbiased. All we are saying that kind is a unbiased kind. The probability of success means equal to tails. This is 1/2 of the total sample means 200 times and 200 times head and 200 times tails. Okay. So that is here. So here 400. See, a coin is tossed 200 times heads, 200 times tails. But here what we have to do, we have to focus on the probability of success only. That is 400 into 1/2 is equal to 200. Standard error of number of success is equal to under root NPQ, N into P into Q. n is equal to 400. And p is equal to 216. 1 by half value. Q is equal to 1 by 1 minus p, that is 1 by 1, 1 minus 1 by 2 is equals to 1 by 2. So it is converted into principle. Standard error of number of success is equals to under root npq is equals to under root 400 into 1 by 2 into 1 by 2 is equals to under root 100 is equals to, if we do take root 100, that is 10. Difference is equals to 216 minus 200 is equals to 6. So you observe carefully, you will get the doubt after completion of this class. See, half value is 1 by 2. But probability of success is 216. So here 216 minus 200. So we got 16 only. So difference divided by number of standard error number of success is equals to 16 divided by 10. That is 1.6. Okay. 1.6. Then decision. The calculated value is 1.6 is less than the table value of 1.96 at 5% significance level. Hence, the null hypothesis H0 will be accepted. There, it can be concluded that the kind is unbiased. Okay, so in this way, we have to do the problem. Then one more problem. 240 heads and 160 tails are obtained in tossing a coin 400 times. Does this appear to be an unbiased coin or not? So you, my dear students, you observe carefully. See, we need to give importance for 240 heads only. See, after tossing a coin like this here, okay, that is 400 times tossed the coin, we got 240 heads. So ultimately 160 is the tails. But we have to give importance for 240 heads only. Hmm? Right, you observe carefully. Null hypothesis, mu is equal to h naught, kind is unbiased. Alternate hypothesis, H rejected. Then setting suitable significance level at 5% significance level, 95% confidence level is 1.96. At 1% significance level, 99% confidence level is 2.58. Okay. Then test criteria. Standard error number of success is equal to under root npq. Then n is equal to size of sample, p is equal to probability of success, q is equal to 1 minus v. That is probability of failure. Then doing calculation. When coin is unbiased, the probability of success means equal to tails. And this is 1 by 2 of the total sample, means 200 times heads and 200 times tails. So 400 into 1 by 2 is equals to 200. Standard error of number of success is equal to under root n pq. N is equals to 400. P is equals to 240. Okay, that is half value. Q is equals to 1 minus P, 1 minus 1 by 2, that is 1 by 2. So it is converted into the principle here. Standard number of success is equals to under root NP Q is equals to under root 400 into 1 by 2 into 1 by 2. Then we got 10. So difference is equals to 240 minus 200 is equals to 4. That is 40. 240 minus 200 is equals to 40. Then standard error difference. Standard error is equals to difference divided by standard error number of success is equals to 400. Sorry, 40 divided by 10 is equals to 4. So decision. The calculated value 4 is greater than the table value of 1.96 at 5% significance level. Hence, the null hypothesis H naught will be rejected. The coin is unbiased. Okay. So in 324 throws of a 6-faced dice, odd points appeared 180 times. Would you say that the dice is fair at a 5% level of significance? See, 324 throws of a 6-faced dice. This problem also same. We need to identify very clearly. See, 324 throws, 6-faced dice, odd points appeared 180 times. Odd points 180 times. The remaining is okay. See, 324, 324. Okay, so 324. 324. 324 minus 180. See, 324 minus 180. That is 144. Okay. In 324 throws of a six-faced dice, odd points appeared 180 times. Would you say that the dice is fair at 5% level of significance? Okay. So here the same procedure. Setting hypothesis, null hypothesis, alternate hypothesis. Kind is unbiased and that is rejected. Then setting a suitable significance level. At 5% significance level, 95% confidence level, that is 1.96 and 1 percentage is 2.58. So test criterion. Standard error of number of success is equals to under root NP Q. N is equals to size of sample. Then P is equals to probability of success. Q is equals to 1 minus phi. Doing calculation here. When the dice is fair, the probability of getting of even numbers would be equal to odd numbers, that is 1 by 2. Hence, in 324 throws of a dice, we expect 324 into 1 by 2 is equals to 162 odd points and even points. Difference is equals to 180 minus 162 is equals to 18. Then standard error number of success is equal to under root NPQ. So N stands for 324, P stands for 1 by 2, Q stands for 1 minus P, that is 1 minus 1 by 12, that is half value. So it is converted into the principle. Standard error number of success is equals to under root NPQ. Okay. So is equals to under root 324 into 1 by 2 into 1 by 2 is equals to under root 81. Okay, we got 9. Okay, so difference is 18 and number of successes, that is standard number of successes is 9 is equals to 2. So the calculated value 2 is greater than the table value of 1.96 at 5% significance level. Hence the null hypothesis H naught will be rejected. So it can be concluded the dice is not a fair. Okay, in this way we have to do. See, this is one more problem. Just I will read it. You do it your home for practice purpose. Okay, if you have any doubt, you can ask the tomorrow class or next Saturday class. Okay, person throws 10 dice 500 times and obtains 2560 times 246. Can this be attributed to fluctuation of sampling, given decision making rejected or accepted? Okay, right. This is the attributes completed with. The next one, test for proportion of success. Test for proportion of success. Number of success completed, proportion of success we are going to do. The difference between proportion next one. See, instead of recording the number of success in each sample, we may record proportion of success. The following is a formula used to test the proportion of success. Standard error of proportion of success is equal to under root PQ by N. P stands for probability of success, Q stands for probability of failure, 1 minus P, N stands for number of total samples. Then this is a calculated value principle, P plus R minus 3 under root PQ by N into 100. Okay, so we'll see the problem. See, 500 apples are taken at random from a large basket and 50 are found to be bad apples in the basket. Assign limits within which the percentage most probably likes. Proportion of bad apples in the given sample is equals to 50 by 500 is equal to 0.1. Hence, P is equal to 0.1. This is the probability of success. So from the, after getting the probability of success value, okay, simply we go for 1 minus 0.1 minus 0.1. That is a 0.9. 0.9 is the failure. 0.9 is the failure. So N is equals to 500. Convert it to the principle here. Simply we have to convert into the principle. That is standard error proportion of success is equals to under root PQ by N. So P is equal to 0.1. See here. P is equal to 0.1 into 0.9 divided by 500. 0.013. Okay, so here we have to assign the limits here. Assign the limits means, see, my dear students, see, this is very much important and carefully you have to observe. See, for example, if you go to purchase, a person went to the one market, vegetable market or fruits market. So he purchased 500 apples from a large basket. Then he found 50 are bad apples. So we have to assign the limits. Okay, generally, if you purchase any item, okay, any item, see it looks very good and fair. Then only you will take a decision. You need to purchase that item. But after purchasing part is completed, after reaching home, you are going to pick up one by one. In the downside or in the middle, there will be some bad apples will be there. Okay, after counting all the apples, we got the total. That is 50 bad apples we found. Okay, we found how many? We found 50 bad apples. Okay, then we have to assign the limits. Assign the limits means these 50 bad apples lies in which tray. Okay, so we have a small formula. That is a calculated value is equals to P plus R minus 3 under root PQ by N into 100. 0.1 plus R minus 3, 0.013. See, 0.013 we got here. This value we have written here only. Into 100. 0.1 plus 0.039 into 100 is equal to 0.13 into 100. Okay, is equal to 13.9. Within bracket, that is upper limit. Then 0.1 minus 3, 0.01 into 100. Okay, so this is 6.1 lower limit, upper limit, lower limit. So the proportion of bad apples in the consignment almost certainly lies between 6.1 and 13.9. So these are the different trays. There are more than 20 or 30 trays are there. But from tray number 6.1 to 6.1 and 13.9, these 50 bad apples will be lie. Okay, the next. Same as usual, like same problem. But in the previous problem, we have chosen 500 500 apples, but here 1000 mangoes. See, 1000 mangoes are taken at random from a big basket, and 100 are found to be bad. Estimate the proportion of bad mangoes in the basket and assign a limit within which percentage most probably lies. The proportion of bad mangoes in the sample given sample is equals to 100 divided by 1000, that is 0.1. Hence P is equals to 0.1, Q is equals to 1 minus 0.1 is equals to 0.9. 1 minus 0.1 is equals to 0.9. Converted into principal. Standard error proportion of success is equals to under root PQ by N. 0.1 into 0.9 by 1000. Okay. So that is 0.0094. The limits within which percentage of bad mangoes lies is equals to P plus R minus 3 under root PQ by N into 100. Okay, so 12.82 upper limit, 7.18 lower limit. The proportion of bad mangoes in the consignment almost certainly lies between 7.18 and 12.82. Okay, so that is the proportion of success. Then the last next method, test for a difference between difference between here, that is proportion of success. Here, difference between proportions of success. This difference between proportions. Difference between proportion of success. So this is a, you see carefully, proportion of success. Test for proportion of success. Then here difference between proportion of success. Okay, right. So if two samples are drawn, if two samples are drawn, right? Please go through this theory part. Okay, right. Difference between proportions. If two samples, see, if two samples are drawn, the difference between the proportion of success population, we may be interested in finding out whether the difference between the proportion of success is significant or not. In such a case, we take the hypothesis the difference between P1, that is the proportion of success in one sample, and P2, that is the proportion of success in another sample, is due to fluctuations of random sampling. Okay, the standard error of the difference between proportions is calculated by applying the following formula. So this is the formula. Standard error P1 minus P2 is equals to under root PQ into 1 by N1 plus 1 by N2, where P the pooled estimate of actual proportion of the population. The value of P is obtained as follows. See, P is equals to N1 into P1 plus N2 into P2 by N1 plus N2. Okay. So we'll go for the same situation. Sorry, we go for the problems. So in a random sample of, see, one random sample of 1000 persons from town A, 400 are to be consumers of wheat. In a sample of 800 from town B, 400 are to be consumers of wheat. Do these data reveal a significant difference between town A and B so far as the proportion of wheat consumers is concerned? Okay, so you wait. See, 1000 persons from town A, 400 are found to be the consumers of wheat. This is the one case. The next one. In a sample of 800 from town B, 400 are to be consumers of wheat. See, town A and town B, two informations are given. Do these data reveal a significant difference between town A and town B so far as the proportion of wheat consumers is concerned? So you see the solution here. Setting hypothesis, null hypothesis, H naught B is equal to H naught, alternate hypothesis HA, mu is not equal to HA, rejected. The suitable significance level. See, at a 5% significance level, 95% confidence level, that is 1.96. Test criterion, this is the formula. Standard error P1 minus P2 is equals to under root PQ. 1 by N1 plus 1 by N2. Okay, right. So to know the P value, this formula we have to apply. That is N1 into P1 plus N2 into P2 by N1 plus N2. Q is equals to 1 minus P. Then doing calculation. Standard error P1 minus P2 is equals to under root PQ into 1 by N1 plus 1 by N2. Then P1 is equals to 400 divided by 1000. That is 0.4. P2 is equals to 400 divided by 800. That is 0.5. And P is equals to N1 into P1 plus N2 into P2 divided by N1 plus N2. Okay. So P is equals to 1000 into 0.4 plus 800 into 0.5 divided by 1000 plus 800. So P is equals to 400 plus 400 divided by 1800. That is 800 divided by 1800 is equals to 0.44. Then Q is equals to 1 minus P. 1 minus 0.44 is equal to 0.56. Standard P1 minus P2 is equals to under root PQ into 1 by N1 plus 1 by N2. 0.44 into 0.56 into 1 by 1000 plus 1 by 800. So final answer is here 0.0234. Calculated value is equals to P1 minus P2 divided by standard P1 minus P2 is equals to 0.4 minus 0.5 divided by 0.0234 is equals to 4.27. So the decision. The calculated value 4.27 is greater than the table value of 1.96 at 5% LOS. Hence, the null hypothesis H0 will be rejected. So in this way, you have to write. Then the small conclusion, it can be concluded there is a significant